In Lab 8.2, you will be looking at design reuse and binary characters on the 7-segment display. So if you recall in 8.1, you created a decoder. The decoder would take in 4 inputs, 4 bits, and these 4 bits came from the slider switches on the DE0CV board. You then output the decimal symbol, or actually the hex symbol, on one of the character displays, which was called hex 0. And it was a pretty straightforward lab. All you really did was you did a process, you used either an if-then or a case statement, and you coded that up. Well, the neat thing about coding something up once is when you get to use it multiple times. So if you notice, you have actually 6 7-segment displays on the DE0CV board, okay? And they're labeled hex 0, hex 1, hex 2, hex 3, or hex 5. What we are going to do today is we're going to reuse your code for your decoder, and we're going to pop it in 6 times into your new top.vhd. But to do this, you do not want to just take your process and copy and paste it in the same file. What you want to do is when you start thinking about design reuse, you want to take that functionality and you want to put it into its own subsystem and then instantiate it. So in order to do this, what you are going to do first is you are going to create a new VHDL file called car_decoder.vhd. You will then declare, and what you'll do in there is you'll just copy and paste your decoder process from 8.1 into this new file. Then in your top.vhd, you will then declare that you're going to use this new file. You're going to use this new thing as a component, and then you will instantiate it 1, 2, 3, 4, 5, 6 times. And then to make sure it worked, what you'll do is you will then drive the input switches, switch 0, 1, 2, and 3, the same 4 bits, into the inputs of all 6 of them. And what you'll see is that all 6 7-segment decoders should show the exact same value. This is to get you in the mindset of thinking about design reuse using components. Anytime you design something that you think is going to be used again, you immediately pop it into its own VHDL file, have its own entity, and then declare it as a component, because once you instantiate it as a component, you can instantiate it as many times as you wish. As with 8.1, you will display the inputs on the LEDs, okay? And that will be what you see. You will take your little D0CV board and you will flip through the switches and you will see all the outputs on here. The neat thing about this lab is you are not going to create a new project from scratch. We're going to show you how to start a new project by copying the past project. What that gives you is it brings in all of the setup information about the FPGA that you're using and any of the pin assignments that you've already assigned. It's really important as you move forward to start using the same naming convention for the inputs and the output ports so that you can reuse the pin assignments, because those things take quite a bit of time. However, we are now using more pins on the FPGA. Last time in 8.1, we used 7 pins to drive hex 0. Now what we have to do is when we add these ports to our top.vhd, we have to also assign their pins. So as part of this, what's going to happen is the first thing you'll do is edit the entity so that it has all of the new things. And what I do in this lab handout is I give you the way that I would like you to declare the entity for your car decoder. That just keeps everybody on the same page. When you go to your top.vhd, here's the way that I would like you to declare your ports. Switch, SW, is still 3 down to 0. LEDR is still 3 down to 0. Hex 0 is from 8.1, but then you're going to add hex 1, 2, 3, 4, and 5 as new output port vectors. Okay? When you do that and you start compiling and synthesizing, it's going to say, hey, I need you to add these pins. So when you get to the process or to the part where it's time to assign the pins, you're going to have to open up Pin Planner and then pop the pin assignments in there. Okay? All right. Then I would like you to think about this, just to give you a little bit something more challenging. And by challenging, I mean hardly challenging at all. Okay? I want you to display the binary symbol. Okay, this is going to be part 2. Okay, so you have part 1, which is what I just described. Part 2 is going to be taking it to the next level. You are instead, you're going to start a whole new project, copy and paste it, just like we showed you. And you are going to now display the binary symbol on the hex displays for the input switches. What this means is, think of this as a whole new project. You are going to, on switch 0, if you click it to on, you should see a 1. If you click it to off, it should be a 0. You're going to take switch 1 and drive it to hex 1. You're going to take switch 2, drive it to hex 2, and switch 3 and drive it to hex 3. Think about that. You're going to use 4 car decoders. And how are you going to do this? Think about this. You have a car decoder that takes 4 input bits. Okay? 0, 0, 0, 0 to 1, 1, 1, 1. And it can display symbols from 0 up to F. Okay? But you're not going to use it like that anymore. You're only going to display a 0 or a 1 based upon an incoming bit. Can you think of any way that we could possibly do this? Any ideas?
Pull the specific bit out of the vector, or you could change the bit vector to just a bit.
Okay, you could change the input to the car decoder, but I suggest you don't do that. Okay, you absolutely could do that. What I suggest is let's use it as is. Okay, consider this. I think your first example was the right one. You have 0, 0, 0, 0. You have 4 bits coming in. Okay. What is the situation where you display all zeros? It's 0, 0, 0, 0. What's the situation when you display the symbol 1? It's 0, 0, 0, 1. So that means the top 3 bits of the 4-bit input to the car decoder are zeros. So all you really have to do is when you instantiate the car decoder, this is actually quite hard to do. I don't know if anybody's watching, but what you have to do is if you just take the switch and drive it to the least significant bit of the car decoder and then take bits 1, 2, and 3, the other 3 inputs, and just hardwire it to a 0, then that car decoder can have 4 inputs, but all you care about is that least significant input bit. Does that make sense? It also turns out that you can actually hard code logic values in the port map. So that's kind of a cool thing that you can do. And what I do is I actually give you the way that you do it. Okay? So look at this line right here. This is instantiating your car decoder. And when I do the port map, what I do is for the input, the binary input, I say I want to put in 4 bits, but I'm going to put 0, 0, 0 concatenated with switch 0. You can actually do the concatenation directly in the port map. Okay? All right, so there's going to be 2 parts, and there's going to be 2 videos, and then you're going to upload the top.vhd as the 3rd deliverable, and that is lab 8.2.